Hey guys, in this video we're going to discuss our last primitive data type, which is Booleans, the data type that deals with truth values. We'll explore the two possible Boolean values and dive into the logical operators commonly used with them, like the and, or, and not. Now let's get started. Okay guys, so I want you to open IntelliJ, create a new project, and create a new class, call it whatever you want inside source. Make sure that the first letter is capitalized, and then create the main method. Now I want you to initialize a variable called x of type boolean and give it a value of true. So there are only two possible values for a boolean. It's either true or false. So let's define a variable y and give it the value of false. Now there is one last thing regarding booleans. We do have logical operators that we are going to use in the future when we learn about for loops, for instance, and if conditions. So we have logical operators and we have bitwise operators. So what are they and what is the difference between them? Okay guys, so I just wanted to explain this in case you're not familiar with the concept. 0 in binary is false and 1 is true. Okay, so this is important because then we want to talk about the logical operators that we have. We have and we have or. These are our main operators. So the and tells us that in order for something to be true, all of its conditions must also be true. So if we have 0 and 0, this is a 0 because we're saying that the two conditions for an event to happen are not present. Okay, so they are not present. This is indicated by false, and therefore the result is false. If we have 0 and 1, this is indicated by 0 because one of the conditions is false. If we have 1 and 0, then this is 0. And if we have 1 and 1, then this is 1. So this is the only case where the result is true because the two conditions for the event to happen, they are both true. Now this is the case of the and. The or tells us that in order for something to be true, for an event to happen, then one of its conditions, at least one of its conditions, must be true. So if we have 0 or 0, this will give us a 0. If we have 0 or 1, then this means that the event will happen and it's true. If we have 1 or 0, again, this is true. If we have 1 or 1, then this is also true. And by the way, these are the symbols that are used in Java for the logical and the logical or. Now, what is a bitwise operator? First of all, the symbols for the bitwise operator, this is the and, the bitwise and this is the bitwise or. So let's mention the difference between them. Let's say that we have 0, 0, 0, 0, 1, and we have 1, 0, 0, 0, 0, 0, okay? So a bitwise and in this case would be 0, 0, 0, 0, 0. Why? Because we're anding each two bits on their own. So this one, anded with the 0 is a 0, 0 with the 0 is a 0, 0 with the 0 is a 0, 0 with the 0 is a 0, and 0 with the 1 is a 0. Now let's do the same for an or. Then the bitwise or in this case will be 1, 0, 0, 0, 1, because we have 1 ORed with the 0 and 0 ORed with the 1 here. So these are the only ones and the rest are 0. So in Java, the logical operators, in the case of an and, if the first condition or if the first value was false, it will not go ahead and check the second condition because we know that if one condition fails, then the result will fail as well or will be false, right? And in the logical or, if the first condition or if the first value was true, then it will not go ahead and check for the second condition's value because we don't care. In this case, since 1 is the least condition for it to be true, if 1 is true, then we will no longer check the rest. But in the bitwise and, for instance, if we have a case like 0 and 0, it will check the first, it will see that the value is false, and it will still go ahead and check the second. This is why it's important to understand the difference between them both. Okay guys, so given what we know now, let's go ahead and create a Boolean result. Let's go ahead and write x or y. Now this gives us a warning because it says that the result is always true. So there's no need really to do this. I'm just showing you how to use the operators. Now let's take a look at the not operator. So I want you to initialize a Boolean result is equal to not x. So when we have not x, this actually just reverses the value. Okay, so let's go ahead and print the result. So here it is. This is because our x was true, and the result stores the not operator on x. So not actually reverses the value. And if we store here not y, it will actually be the same. It will be y was initially false, so the result will be true. Now I want you guys to try this out. Write int number is equal to 4 and int number 2 is equal to 0. Now I want you guys to go ahead and write int result is equal to number and number 2. So what do we expect in this case? We're telling it to store the result of ANDing, bitwise ANDing the number and the number 2. And number 2 is 0. So the result is expected to be 0, right? So it's giving us a warning because it's telling us that this ANDing is always a 0. Because don't forget that int is represented in bits. So number 2 is 32 bits of zeros, and number is 32 bits with the rightmost bits as 100. And then we have here a bunch of zeros. Okay? So ANDing this with a 0, it will always give us a 0. If you change this to 3, this is the rightmost bits of the 4 and 3. So if we AND these together, they will also give a 0. Okay, so it's giving us the same warning. Now let's go ahead and OR this instead. This is no longer giving a warning because the result here is actually a 7. So if we OR this and change it, we will have something like this. 0, 1, 1, 1. And the leftmost bits are all zeros. So this is equivalent to a 7. Let's run this. So here it is. Congratulations for making it this far. We've finally finished the primitive types. Now that we've taken a look at our last primitive data type, which was Booleans, in the next video we're going to step slightly outside of the world of the primitive types and introduce one of the most commonly used non-primitive data type in Java, which is strings. We'll keep it simple, just enough to help us write more meaningful messages and examples, especially as we move into conditionals and loops in the upcoming videos. See you there!